So now putting the cylinder on. Now if you look at the, I think it's the 357, replacing the cylinder on the 357 video, you will see this, but I'm going to sail through it rather than, let's just get this oil can. So I'm going to sail through it rather than go through it in huge depth. A little bit down there and a bit down there. So we oil everything up. I oiled the little end before I put it together. Oil the piston up and the big end and a bit round the main bearings. Now if you remember, or if you don't, go and have a look, we put this thin bit of aluminium round the piston. This is another way of fitting the ring, fitting the cylinder. So let's just get ourselves sorted. This is a tree tie from a tube, from a planting tube. So we just put that round there. Have a look at that 357 refitting the cylinder, and it's quite entertaining, and you'll gain a bit of a further insight into what I'm doing. But effectively the aluminium spreads the load, the tree tie squeezes the ring in, okay, and you want it all parallel so there's no messing about. So then we put the two wooden blocks just under there to support the piston and lower the piston down. I think the last time I did that, the bit of aluminium was a little bit wide, so I've made it a bit narrower. Gaskets on with the gasket sealer, and I'll just bring your attention to this bit here. On these, that is the vacuum up there and down through that hole. That's the vacuum to run the diaphragms. So let's pop the cylinder on, putting it on square, job done. Did you see that? It was easy, wasn't it? So then you undo the tree tie and remove all that lot and put the cylinder on. So let's just do this piston fitting to the cylinder again, just so we cover it thoroughly and I haven't got my fingers in the way. This is on a different saw, but it's just the theory. Bit of oil everywhere, bit of oil in the cylinder. Now, the thin bit of aluminium, and it is quite thin, has a gap, and the gap goes by the ring gap. Then this is a zip tie from a planting tube, so you can undo it. There's an undo there, which is handy. So we put that there, and it's better to have the fixing of the zip tie at the front. So we just fiddle around. See, I've done it again. Let's try that. And you just zip the tie up. And then just push it down, just so it's below the top of the piston. The two blocks obviously support the piston, and they're misbehaving themselves. We'll go round the other side. So as you can see, the ring is compressed. I can see the ring gap. We just need to pull this up slightly so it's right over the ring. And then you get the cylinder with the exhaust at the front, and you put it on like that, and you just push. Hopefully that's made it clearer. But have a look at the 357 video, and it really does go into quite a lot of detail. I'd just like you to be aware, or bring your attention to, this mating face here. So unlike the 023s, where this part of the crankcase is part of the cylinder, like this, see, that's the top half of the crankcase. On these Huskies it's slightly different. You've got this intermediate plate, which is quite good because it means you can remove the cylinder and the piston without taking the crank apart, which is fair enough. But apparently, so I've seen, that you can get a problem with this mating face. So I didn't do it with the other one, but it might be a good idea just to get in there and tighten those bolts up, just to make sure they're tight, because obviously over time they can things can settle and the plastic can squeeze up slightly, and if it's at all loose, then you could have an air leak there, which could mean that your mixture will never be right and the saw will run reasonable but never how you'd like it. And you can test those in situ. You can actually get an Allen key down there with the top handle off to give it a bit of flexibility, and you can get an Allen key into that socket, and I'm trying to do it whilst you see. So you can get that Allen key in there with a bit of box section on the end, and it's as tight as a tight thing, which is great. So having got the cylinder in line, then you put the bolts in. Now be careful, because on some engines it's a coarse thread that holds the cylinder on, and in other ones it's a fine, and in this case it's the fine thread. So just wind those down. Don't wind one down rock hard and then do the next one. Put them all in first and then wind them down equally, or you can go there, 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 like that, just so that you don't get a high pressure point on one side and then try and tighten it up. There you go, you see, into the base, cylinder base, and tighten it up. So having tightened those up, the next thing to do is to organise the rubber mounts for the carburetor, which is relatively easy. Interestingly, you can fit the cylinder and the exhaust and the carburetor in all one lump if you want, whereas with the stills you have to fit each bit separately, and the gaiter goes through that housing in the plastic. But interestingly again, the Still MS261s have got a rubber mounted carburetor like this. Right, this bit's quite tricky to film, so I've got this on the floor, so we're filming down to the camera, and we're just going to have to identify things. Just there is the fuel inlet, which is just a little bit of brass pipe sticking out the carburetor. That's the fuel inlet for the primer pump, so that's the pipe there. Now then, here, let's just move that out of the way, that's the fuel pipe, that's a rubber mount there, and that spigot there fits in that rubber mount, and it's the same the other side. And here is the fuel pipe inlet. So we now have the tricky thing of fitting the throttle. So you'll notice that the throttle is rectangular on that end, and it fits into a rectangular socket which is up in the handle there. Now then, it's very difficult to do this because your hands get in the way all the time. But effectively, what happens is the throttle goes in there and round there. I think we can see that. And then it connects to this lever here. And that is the throttle lever. So hopefully we could see that. Let's just see if we can just zoom into that. There's the throttle lever. And what happens is that hook goes against there and underneath that spring. Like that. But one of the difficulties is there's this piece here which goes that way round, and it sits in there, and the carburetor rod fits through that hole. So it's a bit fiddly, and I'm not going to try and show you how to do that, but effectively what you have to do is put the rod through here and fit the rod into the handle, and then shuffle it all into place, and then connect the throttle bit on the carburetor. So hopefully you can see that that rubber is sitting in that notch, and the carburetor rod is through and it's connected to the throttle. There we go. Fiddly in the extreme. The next thing is the fuel pipe. If you can see, we've identified the fuel inlet. So what you do is you just bring the pipe over and it goes on there. Now you can either do that first, or you can put the rubber mounts in place. I found it easier to attach the throttle rod before you pop the rubber mounts in. The rubber mounts can be very easy, or they can be very fiddly. It's just a matter of moving things around. So I'm just going to hold the saw quite firmly and just lever that over like that. That wasn't too bad. Then the other side is easier. This is the side that seems to be the most difficult. So now we can attach the fuel pipe without getting my fingers in the way, so you can't see what's happening. There we go. So, carburetor fitted. This is just a supplemental. We've got a new ring here. Let me just change my glasses. Ah, that's better. I can see what I'm doing now. So there's a brand new ring here. So let's just try it in this cylinder. Let's pop it in there and bend it round. And I had in mind here that we would just see what the gap is on a brand new ring. It looks like it's half nothing. So let's find the thinnest one we've got. Some of these you can't read very well. There's 0.05 there. So what's the one that's a little bit... Well, 0.05 goes through the gap. What else have we got? 0.2, 0.1. Let's see if a 0.1 fits in that gap. Yeah, a 0.1 goes there. What's the next one? Should have a 0.15 somewhere. 6, 4, 2, 0.15. Got to be careful of that 0.05. It's very easy to bend it. There's a 0.15. Yeah, that's about tight. In fact, it won't quite go in. Yeah, it will. 0.15. Okay, so now all the other thing we need to do, we've established what a ring gap on a new ring should be. Let's get the vernier calipers, the digital ones, the ones that you can read without wearing telescopes, and that shows 1.83. What's it show the other side? 1.86 at the front, 1.87 just here, 1.83. So even on a new ring it's slightly different. 1.85, and it's down to any muck that's on there as well, and any muck on those blades. Let's zero it again. At the front, 1.86. At this side, 1.81. 1.84. Anyway, there you go, you get the general idea. So the ring that we put in this saw is very marginally worn, but it'll be fine. The general idea is the ring gap gives you a good indication of the wear. And of course you don't get wear on the bore very much because it's a Nickel, so it's chrome on top of aluminium. So once the chrome's worn through, you know, it's had it then, but it takes a long time for that chrome to wear away. So you can sort of say, especially at the bottom of the cylinder here, where you've got the rings don't run on it, you could say that that's a true diameter